YouTube channel. In this particular video, we're going to have a prediction of concepts on electricity, which are going to be tested in the coming exam. So if you are new here, consider subscribing so that in time I'm going to do more tutorials, you'll be notified. So let's start immediately so that we can be able to see. Welcome to a tutorial of ProfLearn YouTube channel. In this particular video, we're going to have a prediction of concepts on electricity, which are going to be tested in the coming exam. So if you are new here, consider subscribing so that in time I'm going to do more tutorials, you'll be notified. So let's start immediately so that we can be able to see how to approach different questions which are asked here. You are told to calculate the period of this alternating current. Period is 1 over f. And f was the frequency that was given, which was 60 hertz. So if you work it out, you're going to get 1.7 times 10 raised to the power -2 seconds as the period. You need to understand that we have two types of current: alternating current and direct current. So in this case here, we are having alternating current because it's changing direction. Sometimes you may be given a circuit and then you are asked to label the different components that are there. So you need to understand and know different standard symbols which are done in IGCSE. In this question, we are supposed to calculate average current, but we are given charge and time. So which means that we have to use the formula charge is equals to current times time. And in this case, we were given number of electrons that passed, and then also we were given the charge of 1 electron. So meaning that if we are to calculate the total charge, we are going to multiply the number of electrons times the charge on 1 electron. So once we have done that, we are going to get the total charge as 0.024 coulombs as the total charge. Then we can now be able to use the formula current is equals to charge over time in order to get the average current in this particular question. So if you work it out, remember time here will be time for 1 period, which we had gotten as 1.7 times 10 raised to power -2. So you have to check what we are given here so that we can be able to substitute in. So if we work it out, we are going to get our answer as 1.4 as the current or the average current in this particular part. Moving to another type of question here, you may be asked to define the EMF and the potential difference. You need to understand the difference between the two. EMF is the thought amount of work done to move a unit charge between around a complete circuit, but potential difference is the amount of work done to move a unit charge between 2 points in a circuit or across a component. So in this, you have to know the difference, and we're going to give our difference in terms of the definitions of each of the two. And also, if in a question you are asked to give similarities, you can talk of both of them represent work done per unit charge. Also, both of them represent the amount or is measured in volts or is measured using a voltmeter. So that's what you're supposed to do in question 2. And then question 3 is testing about calculation of thermal energy used from an electrical heater. So you need to understand that thermal energy is IVT, current times voltage times time. And that means you can be able to substitute what we are given. But the most important thing that you have to put in mind here is checking whether the time is given in seconds, and also check whether current is in amperes and the voltage is in volts, because sometimes you may be given current in milliamperes, you may be given time in minutes. You have to ensure that they are in their SI units for you to proceed. Then that question was combined with a question on specific capacity, and we need to remember that thermal energy absorbed by a hot liquid is equals to mass times specific heat capacity times the temperature change. So here we are going to use this thermal energy because that's the amount that was of heat that was supplied to boil the water. So we are going to use that figure, and then we say 17,99400 is equals to mass times specific capacity, which is 4200, times the temperature change. Temperature change will be 100 degrees Celsius. We subtract 22 because water boils at 100 degrees Celsius and initial temperature was 22 degrees Celsius. So at that case, we have to subtract so that we can be able to get the temperature change, which we shall write here and make M the subject of the formula. Try to work this out. And our answer becomes 0.50, less 0.5548 rather. And then now we can be able to calculate the rate at which hot water is getting out. So we can say rate is mass of water divided by the time taken in this case. So you have to remember that the mass already we have gotten it to be we've gotten it to be 0.548, and then the time will be the 60 seconds that already we had. So meaning that if we work it out, we are going to get 9.1 times 10 to the power negative 3 kilograms per second. That's the rate at which water will be getting out from the tap. Moving to question number 4, you have that circuit there. You're supposed to work out the power of the heater, and we are told that the potential difference across the heater is 45 volts. But also you need to remember that power is first we have to work out the current from voltage over resistance so that we know what current was in the heater, and that's going to give us 2 amperes. Once we have the current, we can be able now to say power is equals to IV, which is going to be 2 times 45, and that's going to be 90 watts as the power of this heater that we have here. Moving to the next part, remember here we have a potential difference of 45, but the EMF of the cell was 60. So meaning, what's the potential difference across this section here? This is going to be 60 minus 45, and that's going to be 15 volts. So that means that the voltage across the PD across 10 ohm resistor is 15, and also the PD across component X is going to be 15 because these two components are parallel. Anytime you have two components which are parallel, they have the same voltage. So in this case, we are going to say PD across X is going to be 60 minus 45, and that is 15 volts there. Moving further, this will be 15, those two will be 15 because they are parallel. Then we are going to look at current in the 10 ohm resistor, but we know voltage in the 10 ohm resistor is 15, which we had shown there, and then resistance is 10 ohms. Then we can say current is going to be 15 over 10, and that's going to be 1.5 amperes the current for that. As we also have question number 5 on electrical circuits and how to work out the total resistance. This is the ammeter, this is the thermistor, and then we have fixed resistors there, which is 15 ohms and 30 ohms. So we are going to work out the total resistance of the circuit, but we have two connections which are parallel and one combination of series. So meaning that we are going to have the parallel total combination of the total connection for parallel plus the series one. Here we are going to have 1 over 15 plus 1 over 30 raised to power negative 1, and that is going to give us around 10. Then we shall add plus 20 ohms there. So this is going to be 10 plus, no, this is 10 plus 20, and this is going to give us 30 ohms. That's the total resistance in this particular circuit. Now for us to calculate the ammeter reading, so you see the ammeter is going to read the total current that is flowing this circuit. So meaning that we're going to use the PD, the total PD here was 6 volts, and the total resistance is 30. So we can be able to say current is 6 over 30 because current is voltage over resistance. So which we're going to work out here, and we shall say 0.2 amperes as the current that is running through the ammeter. Moving to question 6, now we have parallel connection. And parallel, what you need to remember is that voltage is the same across all the components. So if the power supply here is 110, it means bulb 1, bulb 2, and bulb 3, each of them will be experiencing a voltage of 110 volts. In a parallel circuit, voltage is the same, but current is shared. So we are told that the switches are closed. Each lamp is rated at 6 watts and operates at its normal working voltage of 110. We are supposed to work out the current of each lamp. So we are going to say that current is going to be voltage over, because we are talking of power, we know power is equal to IV. Then from here, current is going to be power over voltage. So which means that we can be able to substitute the power 60 over 110, and that's going to be 0.55 amperes. So if you work it out, you are going to get that. And the current in the ammeter, you need to remember this is 0.55, this is 0.55, and this is 0.55. So if you want to get the total current that is getting out, it will be 0.55 plus 0.55 plus 0.55, or you can take 0.55 times 3, since we have 3 branches there. They join together so that a current of 0.65 this is going to be, we need to ensure that is this is 1.65. Yeah, this is 1.65. We have to ensure that is actually changed. That's 1.65, but the voltage of the power supply is going to be 110. Total current is 1.65 because we're going to take 0.55 times 3, which is going to be 1.65, this one. But the total power, the voltage of the power supply, because this connection was in parallel, then each of the bulb will be having the same voltage as the power supply. Right, so moving to calculate the resistance of the filament of one lamp when under operating normally or working normally. Remember, resistance is voltage over current, and we know the current of across the lamp is we had gotten at 0.5, so meaning 0.55, so meaning that we are going to say that resistance is V over I, which is going to be 110 divided by 0.55, and that's going to translate to 200 ohms. So this is going to be 200 ohms, and then we can be able to proceed to this question. Question Roman 2 was it's looking at factors that affect resistance in conductors. Now here we are having a conductor of resistance R, and then we have a second conductor of the same material, made of the same material, same cross-section area, but a half the length. So if the resistance of this longer one is R, since this one is short, or a half of that, it means the resistance also is going to be a half. So resistance of the second one is going to be a half. Now, what is the reason behind this? Remember, when electricity is transmitted through a conductor, it's transmitted through movement of free electrons. But as the electrons are moving, they are going to collide with other atoms in the lattice. So that means that if you have a longer wire, there are more collision these free electrons are going to encounter, and then the process, the transmission of electricity is going to be affected. So the longer the conductor, the larger the resistance. But since this second conductor has a half the length, also the resistance will be a half the initial one. Second case, when we are talking about cross-section area, if you have a a conductor of that cross-section area, we can say 2A, and we are comparing it with another conductor of the same length but with a cross-section area A. So the smaller the cross-section area, the fewer the free electrons for conduction of electricity. So meaning if you have a thin wire, it has high resistance because it has few free electrons to transmit electricity. So in this case here, we are going to say if this has a resistance R, this is going to have a resistance twice R because it has a small cross-section area, and it means that it's having few free electrons to transmit. Now in this question, we are told another lamp X as a filament twice filament twice the resistance. So if it has twice the resistance, it means the cross-section area is a half, and the length is double. So we are going to say it's twice the length and the cross-section area is half. So that's what you are supposed to do at that point. Then we can highlight that and move to number 7. And number 7 is talking about a 9.0 volt battery is connected to a 120 ohm resistor in series with wire P. And we are told that the reading on the voltmeter is 2.4 volts. So which means that 2.4 volts is across the 120 ohm resistor. Now, since we had an EMF of 9.0, it means we can be able to know the P potential difference across P. So we're going to look at that. But meanwhile, let's find the current in the 120 ohm resistor. Since we know that current's voltage of our resistance, then we can be able to say voltage is 2.4 and resistance is 120. If you work it out, this is 2.4 divided by 120. If you work it out, you're going to get 0.02 there. So we can write it down, 0.02 amperes. That's the current. Then we are supposed to work out the PD across P. So remember, we were having 9.0 as the EMF, and the PD across 120 was 2.4. So to get P here, we are going to subtract the 2. So 9 minus 2.4, and that's going to give us 6.6. Resistance of P will be current of a voltage of a current. Of voltage, of course, we have 6.6, and then now we need the current. But if you look at this, we have already gotten the current for across the 120 ohm resistor, and this is basically a series circuit, so meaning current is the same everywhere. So here we're going to use this current, which is 0.02, and then the voltage that we had gotten, so that we can be able to work out the resistance to be 330 ohms. Upon finding this, we can be able to now answer the last question of this episode. Then we're going to look at what's happening here. The wire P has diameter D and length L. A second piece of wire Q is made of the same material, so meaning the resistivity is the same. The diameter of Q is a half. So if the diameter is a half, then it means resistance is going to increase by 4. Remember, diameter is going to affect by a multiple of 4, but area is going to be affected by 2. So already we have mentioned that. So we're going to consider the resistance of this one. So we shall say that's the beginning point. So it will be 330. Yeah, so we shall say this is 330 times the length was 5 times, so meaning to be times 5, and is a half. So if the diameter is a half, resistance is going to increase by a multiple of 4. And if you work it out, let's see, that will be 330 times 5 times 4. If you work it out, you are going to get it to be, you are going to get your value being equivalent to 6,600, and that is going to mark the end of this, so that we can be able to focus on the next tutorial.